the nephron, again, I'm sure you did this in lab, but we'll do a quick review. The nephron is the functional unit of the kidney. The nephron is divided into two sections. You've got the actual section where the blood is filtered, that's called the renal corpuscle. And then you've got this section called the renal tubule that basically takes this initial fluid that's removed from the bloodstream and converts it into urine. So you have the glomerulus, and the glomerular or Bowman's capsule. And so basically you've got this knot of capillaries, that's the glomerulus, and then you've got the thing that surrounds those capillaries, that's the Bowman's capsule or glomerular capsule. Put those two things together, that's the renal corpuscle. Now, the initial fluid that leaves the bloodstream and is collected by the Bowman's capsule is called the filtrate. The chemicals in the filtrate are not going to be the same chemicals that end up in the urine. And so when this filtrate, this glomerular filtrate leaves this area, then certain things are going to be sucked out, other things are going to be added to that fluid to make the urine. Now, this is kind of cool. If you look at this section of kidney tissue, basically what you're seeing, this is the little mass of capillaries. And of course they slice through this, and so sometimes they cut into the capillaries. You can actually see little red cells on the inside. And then this space here, that's where the fluid that leaves the capillaries, that's where that filtrate is going to be collected before it goes into the rest of the nephron. So that would be here. That space is that space there. The glomerulus is one of those areas where you have fenestrated capillaries. The afferent arteriole brings blood into the glomerulus, the efferent arteriole brings it out. Now, depending on what picture you're looking at, sometimes they put the afferent on the bottom and the efferent on the top, or vice versa. That's not, you can't just look at top and bottom. The bigger one is the afferent arteriole. The afferent arteriole is a little bigger than the efferent arteriole. We'll talk about lines in a few minutes. So, the Bowman's capsule has two layers. You've got the outer layer, which is easy to see. The outer layer is basically simple squamous epithelial tissue. The inner layer is actually made out of cells called podocytes. And the podocytes actually circle, they're like little hands that circle the capillaries. So, if this was a section of the capillary, each of my hands, this table is where each of my hands would be a podocyte. And then they have these little extensions called pedicels that intertwine with the other podocytes. Does that make sense? Mm-hmm. Okay. And so the little spaces in between my fingers, that's where the fluid is actually going to be filtered out of the bloodstream. Okay, there's what we call the filtration system. All right, and so what you're seeing is that's the nucleus of that podocyte. That would be a podocyte, that would be a pedicel, and then the space in between here would be a filtration system. Then the space in between the parietal and the visceral layers is called the capsular space. Filtration is the process that occurs at the renal corpuscle. The renal tubule, the two processes that occur here are reabsorption and secretion. So the three processes that you need to make urine is you have to filter the blood first, then you got to get the good stuff out of the urine back into the bloodstream, and then there's some other things that you need to get out of the blood into the urine. You have the proximal convoluted tubule. Proximal means closest to the point of attachment, right? My elbow is proximal to my wrist. Right? So the proximal convoluted tubule is the one that's next to the glomerulus, or next to the renal corpuscle, next to the Bowman's capsule. The loop of Henle is this thing that goes down and back up again. And the loop of Henle has the descending limb, so this fluid goes down, comes back up through the ascending limb, and then the fluid goes through the distal convoluted Convoluted means all twisted up, kind of like most of my lectures. From the Bowman's capsule into the proximal convoluted tubule, down the descending limb of the loop of Henle, around the ascending limb of the loop of Henle, and through the distal convoluted tubule. Now, the main function of the proximal convoluted tubule is reabsorption. The main function of the distal convoluted tubule is secretion. Now, I say main function because there is a little bit of secretion that can happen here, and there's a little bit of reabsorption that can happen here. Okay. But the majority of the secretion happens here. The majority of the reabsorption happens here. So, the proximal convoluted tubule is lined with simple cuboidal epithelium with microvilli. Well, that's good because the microvilli give you increased surface area for reabsorption. Makes sense? Okay. And so, any of the good stuff that was initially filtered out of the blood, nutrients, amino acids, glucose, that kind of stuff, quite a bit of the water, is reabsorbed from the proximal convoluted tubule back into the bloodstream. And like I said, a little bit of secretion. But the main thing that occurs at the PCT is reabsorption. The thick part of the descending limb of the loop of Henle is cuboidal. The thin part is squamous. Epithelial tissue. Now, the descending limb of the loop of Henle is permeable to water, but not permeable to anything else. So the only thing that gets reabsorbed out of the descending limb of the loop of Henle is water. And so what happens is this fluid moves out of the proximal convoluted tubule down the loop of Henle. It gets more and more concentrated because more and more water is removed from that fluid. And so the fluid that remains inside the tubule is more concentrated. Does that make sense? The ascending limb is impermeable to water, but it is permeable to sodium and chloride. In fact, sodium ions and chloride ions are actively pumped out of the fluid as it goes up the ascending limb.
How did you say this? Get out?
It's actually little pumps, little active transport. ATP is used, and it's actually pumped out. Because sodium and chloride ions are being actively sucked out of here, this interstitial fluid has a high concentration of ions. That's why the water gets sucked out passively via osmosis on this side. If this side of the loop of Henle didn't actively transport the sodium ions and the chloride ions out here, water couldn't get osmosed from this side. Remember that osmosis is a passive process, and the water wants to go where the stuff is, right? Okay. All right, and then again, the major function that happens in the distal convoluted tubule is secretion. Anything that didn't originally get put into this fluid that needs to be taken out of the blood and put into the fluid, that's what the distal convoluted tubule does. You know how certain antibiotics make your urine turn funny colors? That's the kind of stuff that's secreted into the tubules from the blood. The other big thing that happens here is what's called selective reabsorption. And what do I mean by that? The distal convoluted tubule and the beginning of the collecting duct make the final adjustments to the chemical contents of the urine. This selective refers to the influence of hormones. Things like ADH, aldosterone, calcitonin, parathyroid hormone. So secretion is taking something from a capillary or a bloodstream and putting it into the tubule. Reabsorption is taking it out of the tubule and putting it back in the blood. The hormones, ADH, aldosterone, parathyroid hormone, calcitonin. These guys control the selective reabsorption that occurs at the distal convolution. The rest of the renal, the rest of the nephron is not influenced at all by hormones. From this point up, from the ascending limb up, this stuff happens automatically. As long as the kidneys are working, all of this stuff is happening. Like another way to say that is that from here, this is obligatory. This is going to happen regardless of what else is going on. As long as the kidney cells are fine, as long as the tubular cells are healthy, as long as the blood is flowing into the glomerulus, this is going to happen. It's only this last part that is influenced by those hormones that we've been talking about producing estrogen. And so that's what I mean by the selective reabsorption. So, if you don't have enough sodium in your blood, aldosterone is released. The distal convoluted tubule sucks some of the sodium that would normally get peed out and puts it back in the bloodstream. The blood comes into the glomerulus and leaves the glomerulus. Unless you rupture these capillaries, blood doesn't get into the tubule. Fluid is filtered out of the blood. And that fluid is going to be, by the time it passes through all of this and comes out over here, it's going to be urine. Okay. But if you have blood in your urine, that means that you've damaged the glomerulus. Hypertension, high blood pressure can basically rupture these blood vessels, rupture those little capillaries, and you can get blood in the urine. Infections can damage the glomerulus, and you get blood in the urine. Kidney stones can be coming through here and just scrape this right here, and you can get blood in the urine. But if everything is working correctly, the blood itself doesn't get into here, just the stuff that's filtered out of the blood.